right, everyone can hear me? Perfect. Welcome to United Astronomy Clubs of New Jersey. We're once again back here in Jenny Jump State Forest in Hope, New Jersey, with another great presentation. So, since I see another couple people just strolling down, we're going to give them a little bit to get settled. In the meantime, welcome. Also, welcome to those of you who are joining us online, because that's right, we are live streaming these presentations to YouTube and Twitch. So if you're ever at home looking, man, I wish I had something to do at 8 o'clock on a Saturday night, you can always join us there. And hit those like and subscribe buttons because it does help us greatly. I also encourage you to check out our website, uacnj.org. It's where you're going to find a list of all our upcoming talks, as well as lists of things like our member clubs, the various telescopes we have on site, because each of those sheds actually holds its own telescope setup. And depending on which volunteers we have that night, depends on what telescopes we can open that night. In addition, you can check us out on our social media pages, our Facebook, our Instagram, as well as our Discord server. All great places to find out what's going on, any special events we might have coming up, and even get your questions answered. So, since it looks like most of us are here, you guys here get the safety briefing. It is inescapable. If you need to use the bathroom, that is the porta potty in the back to my left and your right. It is illuminated by red, so when it does get dark, it'll be easier to find. We also have a little museum and gift shop area outlined by red, again, to my left, your right, which I will be manning after the talk because they still have yet to give me the ability to be in two places at once. You really need to work on that, ball.
Sorry. we all have to obey the laws of physics, unfortunately.
Darn those pesky laws of physics. With that, when we do go to leave, do use the headlights, because as much as we don't like having our night vision ruined, we also prefer not getting run over. I'm sure you feel the way. Since the ER is already busy this weekend, let's keep that to a minimum. So, any flashlights we may have, though, as we're walking around, do keep those pointed towards the ground, because we don't want to unintentionally shine a bright LED flashlight in someone's eyes and then they can't enjoy any of the night sky afterwards, because that happened to me last week. With that, tonight's presentation is What's Up in the July Sky? This time given by Paul Fischer. Lonnie, unfortunately, was not able to join us tonight, but he has sent Paul as a approved substitute for tonight. With that being said, Paul has a Bachelor in Engineering and Chemical Engineering from Stevens Institute of Technology and has worked in the environmental and chemical industries. Though always interested in celestial objects, Paul's official start in amateur astronomy was a night several years ago in the freezing cold on his roof with a pair of binoculars where he saw the Jupiter's moons. After some introductory reading, he was hooked. He couldn't escape, and the fact we also had him chained down here in the basement, we don't do that. But it's fun to think about with how much time he actually spends here helping out. Speaking of helping out, he's an active member of Northwest Jersey Amateur Astronomers and volunteers here at United Astronomy Clubs of New Jersey as a board position. And still, even with all that, he still manages to find time to look at the night sky. With that, here's Paul.
Thank you, Kim. And I think by approved, Kim meant that I was the only sucker available to fill in for this evening. No, that's not true. Lonnie graciously provided us this presentation, and unfortunately couldn't make it tonight. So I hope to do his presentation justice. Added a couple slides of my own, so let's get into that. So give every consideration to Lonnie and thank him for all the good information he provided to us today. And if you find anything that's a mistake or you don't like or anything, that's all my fault and has nothing to do with Lonnie. So everyone just keep that in mind. First of all, this is an interesting slide. Right in 1958, at the end of this month, on the 29th, U.S. President Eisenhower signs into law the National Aeronautics and Space Act of 1958. So happy birthday, NASA. Very cool. Lonnie puts this list up like any good presenter should do. Puts this list up. This is what we're going to talk about today. Some things about planets and the moon. Then we get a little bit into a very interesting star and a couple more about the planets and the moon. And then we're going to talk a little bit about other things you can find in the sky tonight because there's an unfortunate fact about the planets up here, at least while we're open. Oof. Man, you guys can't see that at all, can you? I can barely see it, and I'm standing right on top of that. Sorry about that, but it is very light out right now, and there's very little I can do about that at the moment. But this is Taurus right here. And up here is the moon. And just let me make sure that I'm looking at this correctly. And right about here is Mars. So that's Mars. So up here's the moon. Down here is Mars. And then this is Taurus. It is actually one day after the new moon. So favorable for viewing tonight, but unfortunate. And right here you can see this is right before that happened. The darkness is going from the right to the left on the moon. So that was a waning gibbous those several days ago. And right now we are actually in a waxing crescent. It's a waning crescent, excuse me. And now we're in a waxing crescent. And this one here is, let me just make sure I have my facts straight here. Moon near Jupiter. So there's the moon. Oh, and this is, oh, I'm sorry. This is, all right. Now I got it. That was the moon. This is Mars. That's the moon. This is Jupiter. And that happened July 3rd. And maybe we'll come back to those slides when we can see them a little bit better. Here is Mars near Uranus. And that's Mars and Uranus. And that's close to the Pleiades, the Seven Sisters. You might be familiar with that particular asterism. All right, and I said we're talking about the planets, and it sounds pretty exciting that we're going to go see some planets tonight, right? We're not. Here's the problem. All right, Mercury and Venus rise at 7:20, so relatively reasonable in the morning, but they set at 9 and 10 o'clock. We might be able to see Mercury. However, you don't want to point a telescope at Mercury if it's near the sun, and definitely on a public night we don't do that because we don't want any unfortunate accidents of people looking through a telescope at the sun. That would be very bad. Okay, so if the sun sets and we can see Mercury, it's still high enough above the horizon that we can still see it above the trees. We will try to bring it to you, but unfortunately, that might not be the case. It just depends upon how low it is and whether the telescope can see over the trees at Mercury. You can see Mars, Jupiter are both rise in way early in the morning and then set way before you guys got here. So they're right out. Saturn is the only possibility, but not really, because it rises at 11:43 and you guys will be gone. And then Uranus and Neptune are both also in the same boat as Saturn, but even worse, even later. And then Pluto. Pluto looks like it's a candidate here, right? It rises at 9:37 and then sets early in the morning. However, Pluto is not the most interesting object in the world. In fact, you can barely see it even with a telescope. In fact, it's inhabiting a part of the sky that is very uninteresting. It doesn't have any notable stars around it. It doesn't have any, so even if we were to show it to you, because a lot of the scopes can dial into Pluto, even if we were to show it to you, we could tell you it's somewhere in that field of stars, and you would probably have to take a picture of it and then go check some star charts to actually tell which object you were looking at was Pluto. We might be able to tease it out ourselves, but you would have to have some sort of star hopping capability yourself in order to find it through a telescope in a field of stars. So not the greatest object to show the public. So Pluto would be a possibility, but it's a difficult object to appreciate. All right, so those are the planets, and sorry to disappoint you on them. More events in July. We have the new moon. The moon will be a waxing crescent, as I had mentioned, as it was passed by Jupiter, got close to Jupiter. It went from the new moon phase to a waxing crescent. It is currently a waxing crescent, and is seen in the west after the sun dips below the horizon, right? It'll start here and it'll work its way eastward as it goes through its full phase, and then as it becomes a waning gibbous and then waning crescent moon. So everyone remembers that, right? Crescent is the thin sliver, gibbous is when it's fat. And here are those descriptions and the dates associated with them. And so why is this is always interesting. Why is this one and this one called the first quarter and third quarter moon when it's obviously half? Why is it called quarter? If you remember from math and sines and cosines and stuff, right? A period is say you start at 0 when you come to your minimum, come to your maximum, go to your minimum, and then come back to 0 again. So you have to remember that you don't stop halfway through. You have to go all the way down and back up again, and that's why they're actually quarters, not halves. So it's a quarter of the period of the moon, not it appears to be a quarter of the moon right now. In July here, we have the buck moon, which is the Native American full moon names. I don't know exactly which traditions, but there were, I think, traditions that sort of standardized on some of these names, and the July ended up being the buck moon. And Lonnie, if you notice here, Lonnie does a very good job here of representing all these. This is stellarium, but here he just notice that these references, if you are interested at all, these references are right on his slides. So do please visit these sites and enjoy the information they have available. Mercury is at its greatest elongation east. So this is Mercury right here, and you can see it's very close to the sun because that's not a black sky, is it? We have a setting sun behind it, if you notice. The southern delta Aquariids. So this is a very interesting, I didn't even mention this in the beginning. This is another interesting event happening in July. The peak is the 30th. Zenithal hourly rate is 16 possible sightings per hour. The comet of origin is not known with certainty. However, the suspected candidate is comet 96P Machholz. Now, so what is a meteor shower? A meteor shower is us flying through the debris left by a comet that came and visited us and then has left. However, if it left a trail, it left its junk around, and that junk inhabits its trail through the sky. It's a 3D trail in the sky. Think of it like looking down the barrel of a gun or cannon, and we are going through that cannon as the Earth goes around the sun. So that's what's happening, and it results in a thing called a radiant, and that's what this is right here. That's why it's called the Southern Delta Aquariids. This star is Delta Aquarius, and this star is approximately where the meteorites look like they're coming from as we go down that barrel. So we're passing through the cross section of the barrel, and now we're looking directly down the barrel, and that barrel seems to be centered in the sky right there. And that's why it's called the Southern Delta Aquariids. It's next to that star. What is the dentist's favorite time? 2:30, right? Okay, so tonight at on the 30th of July at 2:30 is approximately when the radiant for this shower reaches as close to the zenith as it comes. It doesn't get very close to the zenith. It's pretty low in the sky, but right here is where the let me make sure that I'm pointed in the correct direction there. Oh boy, it's very crowded there. Austriids, Delta Aquariids is this one. So this is the Delta Aquariids right here. All right, so, and this right here, this purple line that you can't see, but I'm outlining it right off of the edge, is actually the equator, but the equator of the celestial sphere, it's above the equator on the Earth. So you draw the equator on the Earth and then project it into the sky, and anything below it is in the southern hemisphere. Anything above it is the northern hemisphere. And even though we're in the northern hemisphere, because we're looking into the sky, we can look underneath the celestial equator and see what's underneath it. And as you can see here, the equator in the celestial sphere is up here, and this is below that. So it's a southern object. So it's pretty low in the sky. But if you go out at, what was the dentist's favorite time again? 2:30 in the morning on the 30th, and you look in the southern sky low, that's where the meteors will look like they're coming from. And you can sit in a chair and appreciate a slow roll of meteors because there's only about 16 per hour, so you might see a few shooting stars that evening. Wait a minute. We have to check something. We're going to go all the way back here. And the 30th, oh, we look good because we're on a waning crescent moon, which means the moon's light will not be interfering too much with these meteors. We had, I gave a presentation in April, and we had one of the bigger meteor showers there, but we had a full moon during the peak, and you were going to see nothing. You would see the moon and not the meteor showers. This one you have a good chance. So 2:30 on the 30th. It doesn't have to be exactly 2:30. If you don't have to hit it right on the nose. It could be 1, it could be 3. Young people will probably want to stay in bed, and people my age and older probably are awake anyway, so go out and take a look. All right, and this is the radiant as I was describing it. So it appears that this is time-lapse photograph. Obviously, if you looked up in the sky and you saw this at one time, all these at one time, that rate is a much higher than 16 meteors per hour. All right, so you would only get one of these at a time, but if you were to take a time-lapse photograph of, it would appear that they're coming from this area in the sky, and that's what a radiant is. All right, here's another interesting thing. You might have seen this in the news. That there's a star that's supposed to explode, right, or something like that. See something having to do with an explosion in a star in the sky? Let's talk about that a little bit. This is called the Blaze Star, and Lonnie does a very good job describing it here. I wanted to add a couple of things, things that I've noticed as people have discussed this phenomenon. The Blaze Star is in a binary system. It has a red giant and a little white dwarf. White dwarf, if you remember, is what happens to a sun about the a star about the size of our sun after it dies and uses all its fuel. It shrinks down to a white dwarf, and the white dwarf is being held up by what's called electron degeneracy. And that electron degeneracy is a exotic form of matter. And if you get into particle physics a little bit and stuff like that, or if you remember from, say, your chemistry class was particularly detailed, you'll remember that electrons, being elementary particles, do not like to share the same quantum numbers as other electrons. And so these electrons, as they collapse into the gravitational field of this dead star, because it's not producing, it doesn't have fuel to produce the pressure to keep it from collapsing anymore. This electron degeneracy, this desire for the electrons to stay away from each other, keeps the electrons excited enough and energized enough to have enough pressure to stay a white dwarf instead of something else. So that's what, if you remember, that's what a white dwarf is. It's surrounded by an accretion disk, and this system is inside a dense cloud from the giant. So this guy's putting out a lot of gas, and this white dwarf is catching some of that in its gravitational pull and pulling it to itself. The orbit period between this binary system is 228 days. Again, you have to come all the way back to the beginning, and that takes 228 days. It's almost circular. It's inclined 67 degrees. 67 degrees to what? 67 degrees to us. It's they are separated by half of an astronomical unit, so half the distance between us, the Earth, and the Sun. An astronomical unit is defined as the distance between us and the sun. So a little over 45 million miles. It's this system's normal brightness is a magnitude of 10. 10 is not very bright. On the magnitude scale, 1 is brighter than 10. The moon and the sun actually have negative magnitude numbers because they're the brightest objects in the sky. This is the history of outbursts from this particular system that you've been hearing about in the news. Not these particular events, but they predicting one will be happening in the near future, possibly tonight, possibly in a couple months. 12/17, 1787, and they actually have some measurements from some other dates. It got as bright as a 2. So that's a lot brighter than 10. On May 12th, 1866, about a 2.5 on February 9th, 1946. And then 215 through 216, there was a sustained brightening. It went from about a 10.5 to a 9.2. And then it dimmed in 2018 in March and April to about a 12.3. So this star has some variability to it. So where did I put these notes? Okay, these notes are right here on this slide. So T Corona Borealis is a recurring nova. Okay, so this is a nova. And we'll go into the differences between a nova and a supernova right now. A nova is a thermonuclear reaction on the surface of the white dwarf. So it's a reaction. It is an explosion. However, no star is destroyed. So this is a surface phenomenon. No star is destroyed. And white dwarfs, this isn't the big explosion that you expect when, or think of when a star explodes, right? This is not that. This is a smaller explosion, still very powerful. It's still a star, and it's still doing something incredibly energetic. However, it is not the biggest thing. It is not a supernova, as many people might think it is. This is when white dwarfs, however, can go supernova. Not only stars that are dying, but white dwarfs can go supernova. How do they do that? When they do go supernova, it's called a type 1A supernova, and it's one of the standard candles used in astrometrics. A white dwarf goes supernova when it accumulates too much mass and surpasses the Chandrasekhar limit. And let me get my cursor back here. Which is about 1.44 times the mass of the sun. So if it accumulates enough mass and reaches this limit, then it will go supernova, and the whole star will go away. It'll blow up. Much bigger deal, much bigger explosion. So I said that it is 1.44 times the mass of the sun, which is the Chandrasekhar limit. TCRB, T Corona Borealis, is currently estimated to be 1.37 times the mass of the sun. So 1.44 versus 1.37 doesn't seem that far off. Now, I don't know how close this object is to how fast it accumulates mass from this other star. So everything I looked up on the web was definitive that this was a nova and not anticipated to be a supernova. So what I'm guessing is that it's just not accumulating stuff fast enough for us to be worried about a supernova. The other thing, and before anyone asks, This is 3,000 light years away approximately, and for a supernova to actually be dangerous to us, it has to be in the 50 to 100 light year range. So doesn't matter whether supernova to us means it'll be a bigger light in the sky, not anything that we actually have to worry about. And just let me see here. Oh, here we go. Discovered by John Birmingham. So I imagine this somewhat surprised looking gentleman here is John Birmingham. They really did not how to take photographs when they first invented cameras. All right, so T. Corona Borealis, as we had mentioned about the Delta Aquariids, probably has something to do with a star and its position in the constellation. And indeed it is. This is the constellation Borealis. It is nestled right next to the constellation Hercules. This is M13 right here. And you could find it, if you can find this constellation, right next to this star right here, on the Hercules side. Now you might think, oh, what the heck does all that mean? Hercules, I can't find any of that stuff. Wrong, because you'll find it tonight. All right, and another. This is actually a view in stellarium of the Corona Borealis, and right here, Lonnie has the correct star. So it's right off of these two stars here. So this is the beginning, and then the next line segment, and it's right off of that line segment. Okay? I'll give you a even better hint. Where the heck is T. Corona Borealis? Well, here you go. You will see tonight, the first things that you'll see are these two stars, most likely. These stars are, this is the zenith right here. So these stars will be right above us. This is at 9:30 tonight. And this is Vega, and this is Arcturus. They'll be the two brightest stars in the sky tonight above your head. All right? And so halfway in between them is this, right between Hercules and Corona Borealis. So there you go. Very easy. Draw a line between Vega and Arcturus. And halfway in between them is right in between Hercules and Corona Borealis. And if you'll remember, between this second line segment here, right off on the outside of T. Corona Borealis, is where that star is expected to go nova. Not supernova, nova. So if you happen to be looking up at any time, not tonight even, but just any time, and you happen to notice those two stars and a real bright thing right here, that's that star going nova. So take a look yourselves. All right, let's talk about some, we talked about how we won't see the planets tonight, which we talked about a couple of interesting events that could happen or will happen that you should take a look for. Let's talk about some of our old friends that happen every year at this time of year. Because if you remember, the Earth comes back around to the same position once every year. So at night we will be facing outward from the sun at that same point in the sky every year. All right, so we see these guys every year at the same time. This is me. I added this part. I like sky maps. I purposely made this a little small so you can't see it, because I don't want to steal their thunder. I want you guys to go visit their site. It's a great reference. All right, so go to skymaps.com. It gives this planisphere type of map. If you'll notice that this is north, this is south. Those both make sense on a map. However, this is east, and this is west. Why is that? There's something wrong there, right? What's wrong? Come on, somebody be brave and answer. Why is it like that?
It's upside down.
Who said that? Raise your hand. Who said it was
Totally not
upside
the
down?
person sitting in the corner.
Oh, you did. Oh, you cheat. You're a cheater. You already know. Yes, it's upside down. So when you read a terrestrial map, the Earth is down there. So you're looking down at the map, reading the Earth. When you are reading star maps, you're looking up at the sky. So if you're pointed at north, then you have to turn the map around and point it to the north again in order to read it, and that swaps east and west. So when you are looking at an app or a chart, a star chart, then you need to realize that you need to be, you can do it in your mind eventually, but I would start with actually putting the chart up to the sky so you can orient east and west correctly yourselves and help your mind get into the right frame to do it. Another thing, so that's what this planisphere is. It sort of locates objects on this planisphere, and the horizon's all around the outside, and the zenith is in the middle. The other helpful thing is this list right here. This is a list of objects to see in the July sky. It starts here with the name or the catalog designation of the object. It'll tell you here what constellation it is, and then it tells you what kind of object it is in this column, and finally it gives a description. So it's a great reference. If you want to get all of what I'm telling you right now over the course of an hour in a very brief look, then you can just look at something like this, and it'll tell you what's up in the sky. And you can skip, no, I don't want you to skip Lonnie's talk. Come often and listen to Lonnie. He's a great presenter. But this gives you a lot of great information yourselves. Here there's a lot of objects, and I'll go through some of them. By the way, these are pictures that I took here. They're not really photographs. I don't do astrophotography. This is EAA, so it's electronically assisted. I'm taking, this is the Polaroid camera of astrophotography. If you remember those things that used to wave in order to get them to develop, that's the level of photography that I'm doing. There are some actual real skilled astrophotographers who are members to this club. This is you know, I was going to make a game of this. I gave this one away already. This one's M13. This is a globular cluster, and you'd be able to see it through a telescope tonight. The two other objects are, one of them's Bode's galaxy, and one of them's the Whirlpool galaxy. What's this one? Someone make a guess. Some of the kids, make a guess. Which one's this? Is that Bode's galaxy or the Whirlpool? That's the Whirlpool. This is the Whirlpool galaxy, and this is Bode's. You'd be able to see all of these objects in a telescope tonight. Obviously, you cheat when you take photographs a little bit. You can get a lot more detail with the photographs just due to exposure, how light works, and a bunch of other reasons. These are more EAA-assisted objects that you'll be able to see through a telescope tonight. I almost forgot the game. One of these objects is the Cigar Galaxy. One of them is Albireo A and B. One of them is the Ring Nebula, and one of them is the Dumbbell Nebula. What's this one? That's the Cigar. What's this one? That's Albireo A and B. If you're here late enough tonight, Cygnus the Swan will be up. This is the head of Cygnus the Swan, and these two stars are an appreciable different color. In other lectures, we say that scientists can tell a lot about a star by the color of its light, and then everyone scratches their head and goes, "Aren't all stars white?" And the answer is no, they are not. And this visually, without photography, you can tell the difference in the color of those stars looking through a telescope. Really cool object. What's this object? Nope. The dumbbell. You can see, because of the photography techniques, you can see a lot more to this object than you can when you're looking at it through the telescope. In the telescope, you can only see the two brighter regions, which end up looking more like a dumbbell. That leaves this one being the ring nebula, and that one looks really cool. It looks like someone blew I don't know, there's too many smokers out there anymore, but if someone still blows rings when they smoke, this looks exactly like that. Probably the kids don't even know what the heck I'm talking about. And these I actually took not too long ago, about a month ago, up here. And these are, I think, at least one gentleman here. I don't know whether he's going to do it tonight, but it is EAA capable, electronically assisted astronomy capable. He'll be over there to the right. He might have this set up so that you can actually see some of these cool galaxies. And these guys are all around the that big bear dude in the sky. What's that big bear? Yeah. Exactly. Also known as the Big Dipper, portion of it, an asterism in the constellation, is called the Big Dipper. And these guys are all around that area in the sky. And this is okay. Again, almost forgot the game. One is called the Hockey Stick Galaxy. One is the Sunflower Galaxy, and one is the Whale Galaxy. All right, this one's hardly a game at all. Let's start with this one. That's the whale, right? By process of elimination, because this one's definitely the Hockey Stick Galaxy, and this one's very definitely the Sunflower Galaxy. And let's go into these catalog designations. I mentioned it earlier on that list on the sky maps. The Hockey Stick Galaxy's catalog designation is NGC 4656. The Sunflower Galaxy's M63. And the Whale Galaxy's NGC 4631. So what are these things? Well, astronomers and amateur astronomers have been putting lists of cool things to look at in the sky together forever. These lists have names, and they're called catalogs. M is the Messier catalog. NGC, oh boy, I didn't write it down, and now it's biting me somewhere. And New General Catalog, I believe. And the NGC was put together by the Herschel family, and the Messier catalog was put together by Messier. And interestingly, Messier was a comet hunter and was writing down a list of objects in the sky that were not comets. So, and now we use it exclusively to look at those things and ignore, no, we don't ignore the comets, but just ironic that he kind of didn't want us to look at these objects, and it's probably the most useful amateur astronomy catalog. All right, and besides other objects in the sky, there's always more learning to do. This is actually my rig, and as cool as those pictures are, and maybe as knowledgeable, or at least not an idiot as I sound, I still have lots of more things to learn about. This right here, you can see the entirety of my rig. This is or one of my rigs. I actually have two scopes. And this is a tripod. This is a Schmidt-Cassegrain telescope, this big orange one here. And this guy on top is new. So I just got that, and what I'm want to learn to do, uh, I had to learn how to mount this on my main telescope and all that type of stuff. All the people who are familiar with guns might know about, for sights, might know about these ring mounts. Okay, so similarly to guns, the telescopes would use a ring mount. And the unfortunate is this stuff is not standardized. You gotta get it for your scope and make sure it fits, and understand that your ring needs to be large enough to fit the scope, not only so that there's adjustment, not only just to fit the scope, whole bunch of other things just to put it together. So I did that, and here I am. What I'm doing is aligning this scope. And here you can see the scope in the field, and right here is a Comcast broadcast tower. And I'm not actually looking at that. I'm looking at this tiny cell phone tower on the top of this mountain. And what I'm doing is making sure that this scope and this scope are both pointed in the same direction before I look at a star, because this is maybe a couple of miles away, and stars are a couple or tens or hundreds of light years away, which is trillions of times that. So you want to make sure that that angle is correct, because multiply it by how many trillions, billions of miles, whatever that conversion ends up being. Interestingly, when I pointed my main scope at that and got this adjusted, in my main scope on this tiny little tower in the distance on the mountain there, I could see two crows hanging out on the top of the tower, having a good time, whatever crows consider a good time. All right, how do you get started? That's where I am in my journey. How do you all get started? Everything you need to start birding is what you'd need to start maybe your journey in astronomy. A good pair of binoculars and starting to get familiar with the sky is the way to go to start astronomy. One thing about it is that they're easy to, you just look at what you want to see in the sky, right? So not that hard to operate. Second thing is that their price, these are all in the $100 to $50 range. I know my wife has a pair of Nikons that were like $200 when we bought them or something like that. So a relatively modest investment in optics. More expensive are these hobby store telescopes. Lonnie put these up here. I don't necessarily recommend these scopes. They're limited in what they can see. So if you're looking to see cool stuff in the sky, you can see the moon and maybe the planets in these. Otherwise, it's difficult to see anything else with using these telescopes. If you're investing for a young one, this might be the way to go. That way you've invested a little bit of money but haven't broken the bank by investing a hobby that might be put aside very quickly. These are more a starting scope for someone who thinks they want to take up the hobby. Notice that these are all less than $1,000, and they're good scopes. You'll be able to see any of the telescopic objects I showed you in these scopes. I recommend these guys. These are Newtonian, and they are with a Dobsonian mount. So this mount is just a swivel, up, down, left, right, and so you can point it anywhere in the sky. It does two things for you. One is it gets you familiar at a low price point of things in the sky, and second, it forces you to start learning the sky. That's a very important part of astronomy. You don't have to know everything right away, but you start wanting to get familiar. Like I said, these are all less than 1,000. These are starter go-to mounts. So these are computer driven. They will know where objects are in the sky. However, you have to know enough about the sky to tell it where it is looking to align it in the first place. So you need to know 3 stars in the sky. And if you want to take it out on a particular date, you have to know 3 stars that are up that night. If you go out 2 months later, you don't want those 3 stars to have disappeared and now you don't have any stars and you have to wait till next year to use the scope again. So you have to know at least 20, 30, 40 stars during the course of a year to properly align these scopes. Plus, they're not always 100%. They'll go right on the money. When they're working great, they will. And don't get me wrong, they're great when they work. But sometimes they're a little off, and you'll have to realign it. And it helps to have the knowledge that you gained, maybe from using one of these scopes first to find the stars when you're having a little bit of difficulty, or you have to align it in the beginning of the night. All right, so we're almost to the end here. Here's some of Lonnie's references. Of course, we're up here at UACNJ, Sky and Telescope, Space.com are all great sites to visit, and Astronomy.com. These two are magazines. Space.com is I believe that's also a magazine, but has a very huge online preference. These are various apps that you can use. Sky Safari is excellent. Night Sky. The other ones I'm not as familiar with. Stellarium is also. Stellarium is a lot of the computerized charts that you saw in the presentation that came from Stellarium. Here is a bigger bigger push to get you to use Stellarium. Stellarium is very powerful. Celestia and project.space, mobile is another reference. Again, Stellarium. And finally, just reminding you about what we talked about. We talked about some of the conjunctions, about Mars being near the moon, Jupiter being near the moon, about the new moon being yesterday, Mars being near Uranus, when the full moon is, Mercury being close to this, being as far east away from the sun as it can be, the moon near Mars and Jupiter, and then we talked about the Delta Aquariids and when T Corona Borealis goes, it's not a supernova, it's a nova, right? This is Lonnie. For anyone who's familiar with Lonnie's What's Up talks, he does Astronomy in Motion and Mars at Your Fingertips. He does some, besides being a fellow Stevens alum, he does all these cool things with projecting actual photographs on mathematical models of like Mars. So he takes photographs and puts them on a globe of Mars, and you can play with that globe like you are playing with a globe of the Earth. So kind of cool. And probably, if you remember Mercator projections and all that type of stuff, not insignificant. Doesn't take insignificant amount of smarts to do that type of thing. So that's Lonnie. And here we are at the last slide. Thank you, everybody.
All right. Thank you, Paul, for a great talk. So we are going to be having a Q&A session. But before that, for those of you who snuck in during the presentation, you must have the safety briefing, like everyone does. If you need to use the restroom, that is the porta potty in the back to my left, your right. We also have a little museum and gift shop area, which I'll be manning after the question and answer session. We are using our headlights when we go to leave because we do not want to get run over. The ER has enough cases this weekend. We do not need to add to it. That being said, any flashlights, do keep them pointed towards the ground because we don't need to unnecessarily have flashlight raves where people are getting night blind because of that.
I'm just checking the sky to see whether you can see those 2 stars we talked about.
Not quite
Not quite yet.
It's a little too. So for the question and answer session, how it's going to go for the people here, you just raise your hand and wave it about. I'll come to you with the microphone because if you have a question, chances are someone else might have that question, and we want our online audience to be able to hear them. Let's start you off with an easy online question. What's your favorite planet?
Earth. Earth is my favorite planet. I highly recommend.
It's the only one with chocolate.
Yeah, to look at Jupiter, you can see a lot of detail on Jupiter. So I find it really cool. Plus the moons are cool, and Saturn is always the stunner when we show that to the public. Seeing those rings just doesn't look real when you look at it. You are looking at Saturn, but it just looks otherworldly when you well, I guess that makes sense. It is another world, so that would make sense. But it just looks kind of cool and spooky when you look at it for the first time.
All right, question out here. I don't even get crickets this time. Let's move on to a little bit of a harder online question.
Oh.
I saw a hand, but then it keeps going down. There.
Thank you. For this nova, we're pretty sure is about to happen.
Yeah.
I think you said it's happened before, and so we're pretty sure it is going to happen, like in the next week or so, or
not next week. I think it had like a 6-month and then that's still a probability.
okay.
Right. It's not. It depends upon how much stuff has accumulated on the surface of that white dwarf star, and so I don't know that they know that with such reliability that they can actually predict it. So, but they are expecting it sometime this year, and by September, I believe, is the information I saw online.
Okay, thank you.
Mhm.
And one quick one too.
Sure.
So you said it's got to get almost up to the mass where it would have a supernova. It's also 3,000 light years away. So is there a chance that maybe it's already had a supernova and we just haven't been able to see
No,
it yet?
it wouldn't be there if it had a supernova. There'd be a supernova remnant there, and not not a star anymore. The Type 1a supernova destroys the object. It's one of the brightest things in the universe. It will outshine all the stars from the galaxy. So you add all the light from all the stars in its host galaxy, and it will outshine all the light from all the stars in that galaxy. So really powerful event. It's actually one of the standard candles. That's how we know how far away some galaxies are, because we know the mass, because that's Chandrasekhar limit. We know the mass it went off, so we know the physics of how much material's going boom, and we can so we know how bright it was there, and now we can measure the brightness it reached once it reached us, and now varying with the square of the distance between us and them. We now have 2 variables and 2 equations. We now have the degrees of freedom we need to solve that equation, and now we know how far away that galaxy is. So that's how these are used as a standard candle. And like I said, they're significant and useful as a standard candle because they outshine the galaxy that event happened in.
Right. So our next online question is, do we have any more solar storm events where we might end up getting aurora down south here in New Jersey or Pennsylvania again?
Again, these are probabilistic in nature. However, what I can say is that it's likely that we will get more aurora, etc. The sun is at a solar maximum in its cycle, and if you go back to the UACNJ website, if you weren't bored enough with this presentation, you can go and see another of my presentations about how the sun works and about the solar cycle and why it happens, etc. But we are at a solar maximum now, and the sun is at a high state of activity in the solar cycle.
All right. And there was a question here.
Has anyone seen comet 13P Olbers?
12P?
P
I don't know.
of June, it hit the perihelion. That's 7th or 8th magnitude.
And what magnitude did you say it was? 7 or 8. I don't know. I haven't seen any pictures of it. I think someone took a picture of it, and I did not look at the picture. Unfortunately, someone up here might have viewed it. I did look at 12P. One of the comets that is relatively close to us now, and however, that is a very southern object. Doesn't get far above the horizon, so it'd definitely be below the trees. And I don't think it's a particularly bright either. I think it's like 14th magnitude or something at this point. So unfortunately, no comets tonight, most likely. But I think someone earlier this year did take a picture of the comet. I didn't see it myself.
All right. So our next online question is, actually, this was one for during your presentation. When you were talking about that purple line, did you mean the ecliptic and not the equator?
No, I meant the equator. That's a good distinction. So if you remember on the celestial, okay. I don't have any supporting diagrams to show you, but in the sky, you remember that the poles are where the poles are in the sky. So the north celestial pole is above the North Pole. The southern celestial pole is below the Earth's South Pole. The equator on the Earth is below the equator on the celestial sphere. I have to move back. Sorry, sorry everybody at home. So those objects that exist on the Earth exist in the celestial sphere. There's this other very important arc in the sky, very important great circle actually around the celestial sphere called the ecliptic. And what that is if you remember, the sun, our Earth, is currently, the northern hemisphere is leaning into the sun a little bit by about 22 degrees, 23 degrees. So that tilt, axial tilt, is has to do with the ecliptic plane. So the Earth is tilted compared to the plane of the solar system. And that ecliptic plane, that whoever that was who asked the question is referencing, is the plane on the celestial sphere, the arc on the celestial sphere that the solar system lies in, not the equator, which is above our own equator. It's tilted compared to our equator by 23 degrees. It's in the same position during the equinox the autumnal and vernal equinox, and during the two solstices is when it's maximum distance away from the equator. So right now we're relatively close to the summer equinox. You can expect that the that ecliptic plane is a good bit south of at night of the equator. And so I did not actually mean the ecliptic plane. I did mean the equator. But if you want to look for the ecliptic plane, knowing where the equator is, it's currently south of the the ecliptic plane is currently south of the equator in the night sky. In the day sky, it's above it.
All right. Was there another question out here? All right. So our next online question is, if the sun had a nova event, not a supernova, just nova event, would it be possible for people to survive on Earth?
So
And
no, because they would be long dead already, because you need to have a white dwarf sun binary system to have a nova event. So nova is very different from you can't have a nova event separate from a white dwarf to have that thermonuclear reaction, to have it on that surface. That nova needs to happen on a white dwarf. And so we would be dead already because our sun would be a white dwarf. And there'd be another sun there too, which isn't there. So
a lot of strange
if our
things
sun
would have
if our
needed
sun
to happen.
supernova, our sun can't do that either. Our sun is just not big enough to go supernova. However, just the idea of the sun running out of energy and it becoming a red dwarf is a very energetic event, and we're only the third planet out. So sorry for those people, 4 or 5 billion years from, or what is it, 7 billion years from now, they're not going to have a good day that day.
All right. Questions? All right. So, two real quick ones. How many different space object catalogs are there?
I don't know.
So that's something we'll have to do research on.
There's one designated CR, I know. There's the NGC IC. It's 2 catalogs combined. There's the Messier catalog. I've seen other catalogs. I don't think we have a shortage of catalogs. But certainly the main ones, if you want to start, definitely begin with Messier. And you're going to move on to the fainter objects once you have the equipment to support it in the NGC IC, and then there's other catalogs you can explore.
All right. And if you have any last minute questions online chat, now's the time to get them in. Another online question is, if the Earth's rotation changes our celestial perspective, Sorry, my mother Englished wrong. Can earthquakes change Earth's celestial perspective? I'm guessing we have giant earthquake on Earth and suddenly Earth is tilted this way instead of that way.
I don't know that it can appreciably change the tilt. I think it can. I think in the terms of like seconds, it can change a little bit the speed at which we are temporarily, so that we have to adjust time on it, on very sophisticated clocks. However, I don't think that we could just be that earthquakes are just energetic enough to rumble the Earth significantly to adjust it in the Earth. I think if an earthquake goes that does shake it that much that it affects the orb,
that's an apocalyptic level event.
That no one will be worried
dead.
about the effects that it had on the sky. It would be a very, very bad day for all of us.
All right, I see a question out here.
Hi.
Hi.
Will we be able to see the entire summer triangle tonight?
Oh, definitely. Vega.
Vega, Deneb, Altair.
Okay, so I can see Vega right now. So that's one part of the summer triangle. So that bright star over there is Vega, and further east is Deneb, and then south of those two is another bright star called Altair. And those three stars make the summer triangle, and you will if you can't see them right now, you will definitely see them within the next 15 minutes.
All right. So it looks like that took care of our online questions. Any last minute questions out here? All right. I want to thank you all for joining us. For those of you who are here, enjoy our volunteers running our telescopes. For those online, do hit those like and subscribe buttons. Don't forget to check out our website, uacnj.org. And have a great night, everyone.
Thank you, everyone.